been a cancellation, so we're actually moving straight to the second paper of today, which is Jeremy Featherstone from JDR Cables. So I'll just give you some background to Jeremy. Jeremy's a chartered engineer. He's the product development director at JDR Systems Limited. Jeremy's worked in subsea cables for some 30 years. He started his working life at SMD on subsea telecom cable burial equipment, before spells at Global Marine Systems on telecom cable installation, and then Centrica Renewable Energy on subsea power cables for offshore wind farms, and now JDR, where he leads the product development team. Please welcome him to the stage.
Thank you very much, Philip. Good morning, everybody. It's a pleasure to be here. So I hope, can everybody hear me okay? I'll take that positively, thank you. So here we are in Dubai, and you might think, why are we discussing offshore wind when there isn't really currently any offshore wind industry in this area? What it does offer is a good case study in what a change to the whole energy production infrastructure can do to the cable market. And particularly what we see with renewables is they're much more diverse geographically than your traditional power generation sites of large nuclear or gas power stations. And this greater geographical diversity is very good for the cable industry because it means more cable demand to bring the energy into the grid. So I'm going to be talking about the growth of the market for offshore wind energy cables in Europe, what the technical and environmental challenges are, and some of the cost reduction initiatives that we're working on. A particular one is move to higher voltage array cables, which I'll talk about. It's the 66 kV development. And then I'll try and tie that into what that might mean for wind power generation infrastructure in the Middle East. So a little bit about JDR to start with. So historically, we were very much an oil and gas company. This slide shows the range of our products. So the bottom right-hand side is a lot of umbilicals for oil and gas applications. And those would typically involve low voltage signals, maybe some medium voltage up to 11 kV power, and hoses and tubes. And if you step back 10 years ago, that was at least 75%, if not more, of our business. If we look at it today, it's completely turned around. 75% of what we're doing is in the renewable side, offshore wind, as we see in the top part of the slide, and there are 25% is in the oil and gas market. Okay, that's partly a reflection, of course, of the fact that oil prices have been low for quite a long time, but it is also a very fundamental shift in the market for subsea products as we see it. Now, we've had two factories, in fact, in the UK now for many years, but this shift towards the renewable sector has meant much higher voltages, and we've historically bought in the power cores to make these subsea cables, and primarily from TF Cable in Poland. And last year, JDR became part of the TF Cable group. TF Cable had become the biggest supplier to us, so it was a very good fit, actually, that TF Cable bought JDR. There's almost no overlap of products or manufacturing capability. Just to give you some idea of the global spread, the group has 8 production plants, 6 operating companies, including one here in Dubai, led by my colleague Anil Kankar. For us in the renewables side, the key plant actually is the Bydgoszcz factory in Poland, which has 8 CCV lines, and is able to produce cables up to 500 kV and up to 3,000 millimeter squared. A really key part of any cable production, of course, is not just your manufacturing capability, but also the high voltage testing facilities to support it, to qualify the product, to test the product, and to ensure quality. So our business model has been to make medium voltage cables, single core cables in Bydgoszcz in Poland, and then ship them by road to the UK. And this slide here shows the Hartlepool UK factory that we have. So on the top left we see the factory site here. So as you can see, it's well positioned for quick access out to the North Sea. On the right-hand side is a vertical laying up machine, and the power cores come in on those blue drums by road. Then they're laid up into the 3-core cable, and we have, this is one of the armouring lines. We've actually got 2 armouring lines. And then a feature of any subsea cable factory is that you need a lot of cable storage. Here's some cable storage here. We have a series of 4,000-ton carousels to store cable, finished cable. So just to talk a little bit about offshore wind. Within the offshore wind market, there are 2 types of cable. The export cable, which will take the power from the field back ashore, and then the array cables, which will link up each individual wind turbine back to an offshore substation. This graphic on the bottom right shows a typical wind farm. This is actually Thanet off the southeast corner of the UK. Each of these dots is a wind turbine. These are all linked by array cables to an offshore substation there. And then from the offshore substation, there's the export cable all the way back to the shore, linking into the grid. Now, if you went back a couple of years ago, almost all these export cables, including this one, would be 132 kV. But now, as wind farms have got larger, we're seeing increasingly 220 kV export cables. And even, and this is definitely the trend for the future, some of these are now moving to HVDC, and typically plus or minus 320 kV HVDC. The side that we've been much more involved in is the array cable side. So, and this cross-section, this image here shows an array cable. You've got the 3 power cores here, a fibre optic, single armoured, fillers, and rove. So a relatively simple construction. Until this year, almost all offshore wind farms have worked at 33 kV for array cables, but now there's a move increasingly to 66 kV. And just to give you a feel for the market size, it's roughly, on a global basis, currently about 1,000 kilometres a year, which equates to about 15,000 tonnes of finished product, and is probably in the order of 250 million US dollars of value. So this is quite a significant market in its own right, manufacturing array cables. So this graphic shows the projects that we've so far delivered. As you can see, they're mostly in the North Sea. Primarily, these ones are all in the UK zone, but we've also delivered several projects in the German sector as well, and the Dutch sector. And the far right graphic shows the production since 2010 of different suppliers in Europe, and the cumulative amount over the last 10 years. So you can see it on this graphic, JDR is the leading supplier, followed by Nexans. Although on the bottom 3 here are Prysmian, NSW, and Dracker, which of course now are effectively becoming one company. So if that was redone to reflect the whole Prysmian group now, you would see a fairly equivalent division between 3 key suppliers. But of course there are more suppliers as well. So what are the market trends? How big is the market? Where's it going? So if you just look at offshore wind in Europe, it's now reached 14 gigawatts of installed capacity. So that's becoming a sizable market. In the UK, approximately 5% of UK electricity is generated from offshore wind, and that's increasing all the time, and it's expected to be 10% by 2020. I know it's true to say that Europe very much leads the offshore wind industry. In the USA, there's 8 gigawatts of offshore wind in the pipeline, so potentially that's a big market, although at the moment only 30 megawatts is deployed. So there's a long way to go before we see the US offshore market becoming anywhere near as big as the European market. The onshore market is much bigger. China already has 151 gigawatts. Europe has 146 gigawatts. USA has 82 gigawatts. And the recent statistic I could find for Middle East and Africa, which combines the two, is only 4 gigawatts. So you can see there's a massive amount of disparities of the amount of wind power that's being deployed in different areas of the world. So this is a very, slightly UK-centric presentation here, but one website that I find a very interesting website is the GridWatch website. I don't know if anybody in this audience is familiar with this website, but what it shows, you can go onto it and it's delayed by 15 minutes. It tells you where the source of energy, of electricity is coming from in the UK at any one time. So when I was preparing this presentation, this was a snapshot of what it was at that time. And I don't know if you can see the dials, but at the time, this was on, I think, a Thursday morning, UK demand was 36 gigawatts. And renewables made almost 49%. So that's a huge proportion of the electricity that was generated was coming from renewables. And that came from primarily wind, but also solar energy and some biomass. So one of the things that's extraordinary about that to me is that even in the UK, on an average April day, solar was making a significant contribution to our energy. And if you look at the bottom right graphic, this shows here, this was the last 24 hours, and this sort of eye of yellow colour is the solar power input that's generating electricity in the UK. So with almost no fuss, the solar industry, even in the UK, has become a reasonably important player in the electricity generation market. The other thing that's interesting on this from a cable supply point of view is we're seeing here wind being a very high percentage. About 25% of the overall electricity production at this time was from wind, but also interconnectors become important. So these 4 dials here, there are 4 current interconnector systems linking the UK to Ireland, to France, to the Netherlands, and these show the flow of energy going in both directions. And at this snapshot, that totals about 7% of the energy, of the electricity generation in the UK. So in both cases here, this is importing energy from Europe, but it can go the other way. And of course, the thing that provides the base load to all of this in the UK market is nuclear power at about 20%, and then gas coming in and out to fill up the gaps of demand, gas and interconnectors between them coming in and out. And at this snapshot, gas is 23%. But I think one of the key points I wanted to get over really was that renewables has become a significant part of the infrastructure, and even solar in the UK has become a very significant part of electricity production. So in terms of the current market drivers in Europe in offshore wind, what we see as part of the supply chain is the absolute dominant thing is cost reduction. And this is cost reduction towards creating a subsidy-free market. And what we're seeing now is the developers, the people actually building the wind farms, are competing between themselves fiercely for projects at low subsidy levels or even zero subsidy levels where the transmission assets are built by the grid, as we're seeing now in the Netherlands. So this is a real change actually from a few years ago. A few years ago, the governments had to encourage developers to build the wind farms by providing subsidies. But wind farms have been successful investments. And behind this are pension funds and other large financiers who like investing in wind. They may not like to take the construction risk, but once the wind farm's built, they like to invest in them. What it gives you is historically, what we've seen so far, it's been a good investment, providing good returns. Some of the price, they may be well known. Of course, the cost of the fuel for an offshore wind farm is absolutely known, and that's a really big difference between investing in a coal or gas-fired power station. You know exactly the cost of the input, which is nothing. That's the wind. What of course is not known is the long-term maintenance costs are not so well known. But nevertheless, we see there's a lot of parties wanting to invest in offshore wind. And they're financing the developers are competing with each other. So we're creating a really strong market. So that's the good news. From a supply industry point of view, the less good news is this push in order to make these projects go ahead at zero subsidies or very low subsidies, the costs have to come down. One of the most competitive developers is Dong Energy, or Ørsted as they're now called. And this is one of their graphics, and quite a striking claim that offshore wind power is now cheaper to build than coal and gas-fired power stations. And the right-hand graphic shows the way the costs are declining very quickly. So how's that being done? How are the costs reductions being achieved? So one of the key things here is economies of scale. Bigger wind farms, more wind farms, and bigger turbines. So this graphic here shows the way turbines have grown. This is all to scale. There's a Boeing 747 jumbo jet flying overhead to give you some idea of the scale. But if we go, as we've gone up to 8 megawatts on the turbines on the right-hand side with rotor blades of about 80 meters long, and the next generation is even bigger. GE have now announced 12 megawatt machines. These will have rotor blades of over 120 meters. So they're getting absolutely bigger and bigger. And of course, for each unit, you could get some economies of scale because you're only doing one foundation for a bigger unit, for instance. Standardization is helping. We're seeing a focus on utilization. So both in terms of manufacturing capabilities and in terms of deployment. So if you're running an offshore construction vessel or indeed a cable factory, the last thing you want is 4 or 5 months of intense activity, followed by the rest of the year with nothing going through your works. And framework agreements are becoming a bigger part of this that just enables the whole industry to manage the capacity and demand better. We're seeing with this, obviously the cost reduction is leading to margin reduction in the supply chain. What we're seeing though is the projects are very large. Large projects, lower margins, but overall a prize. And vertical integration and consolidation. So the fact that TF Cable bought JDR is an example of that. We're seeing other consolidation, we're seeing around the Prysmian Group, for instance. But of course, we're also seeing new competitors coming in, non-European cable manufacturers trying to entering this market, and the whole global growth of offshore wind. So at the moment, Taiwan, for instance, we're beginning to see projects starting in Taiwan, projects starting in the US. So I might have given a rosy picture there of offshore wind in many ways. However, any new project takes a lot to get off the ground. Now, I won't go through all of these in any detail, but what we see in Europe, and I think what we'll see in the States and many other parts of the world, is actually it's difficult and hard work to get a project off the ground. All of these factors have to come together. You've got to get a grid connection agreement. You've got to get the landowner permissions to run cables back to your onshore substation. You've got to agree with the fishing industry how you're going to deal with claims around the interaction between cables and the loss of fishing grounds. You've got to deal with the shipping industry. Military, radar interference has been an issue. Leisure and tourism, which can go both ways. In some areas, actually, the local leisure and tourist industry might welcome the presence of offshore wind turbines as being a feature of interest to be seen from the shore. In other areas, completely the opposite reaction will be received, where it's seen as the worst possible thing that could happen. Anchorages, ordnance. In the North Sea, there's still a lot of ordnance left over from the world wars. This needs to be cleared. Cable and pipeline crossings. So all of those human activities. Then, of course, there's the more environmental activities, aspects. Quite often, the landing points where you want to land the cable might be protected wetland, salt marsh. Sea defences can be important. You've got to agree with environmental agencies how you're going to land the cable. Reefs have been very important. Bird migration, bird strikes, bird breeding areas, sea mammals, the presence of dolphins or porpoises in the area. In Germany, there's a criteria which you're not allowed to heat the seabed up by more than 2 degrees above the cable. So that creates its own issues. So there's a whole raft of environmental issues that need to be met. And then, of course, there's the commercial issues as well. What's the subsidy regimes? Can you make the business case? Is there a supply chain ready to supply? Does it have the scale? Is it economically viable? Can you create the local content that a lot of authorities want to see to ensure that jobs are created and retained in that local area? And all of these need to happen. And certainly in the US, although the potential is very large, these factors have tended to stack up and delay projects. So, and actually just in the UK, for instance, onshore wind, the development in onshore wind now is very quiet, and that's because there isn't a subsidy regime by the government to support it, and it's become very difficult to get planning permission for onshore wind. But that's helped the offshore industry, which seems to be less constrained than the onshore wind industry in the UK. So I'm just going to talk a little bit about, more specifically on cables now, and the cost reduction of array cables. So here are two graphics of 2 wind farms. They're both the same. One is linked up with 33 kV cables, and one is linked up by 66 kV cables. In the middle, we've got an offshore substation. Each of these dots is a wind turbine. And at 33 kV, with a typically 7 or 8 megawatt turbines, you can get economically typically 4 turbines onto a string. Whereas if you increase the transmission up to 66 kV, you can get 8. So if I now add in the cables that go back to the offshore substation, what we see is that the 33 kV requires a large volume of cables going into the offshore substation, and 66 kV half that amount of cables. So the overall effect of this is that typically the reduction in cable length required is between 20 and 30%. And of course, that's 20 or 30% cable you're not having to make, but it's also 20 or 30% less that you have to install, and the offshore substation becomes a much simpler structure. So this is what's driven the move from 33 kV to 66 kV as part of cost reduction, and it fits with the bigger turbines that are coming on stream now. So this doesn't happen overnight. It was originally proposed by an Atkins Carbon Trust study in 2011. In 2013, we received some government funding to look at lead-free 66 kV array cables. And in 2015, the Carbon Trust, together with some offshore, some of the utilities, partially funded 3 cable suppliers to qualify product. We did our qualification in 2016, and the first commercial projects were delivered in 2017. Nexans were actually the first to deliver one for the EDF Blythe project. We were second with supplying to Vattenfall, and then those are both demonstration projects, but then the first really big project to embrace 66 kV has been East Anglia 1, 714 megawatt project, which JDR secured, and we're currently manufacturing that now. We've also had an eye on floating wind projects, and the first 66 kV floating wind project in Europe is the Windfloat Atlantic project off Portugal, where we'll be supplying dynamic array cables of 66 kV. The answer is yes. So if you looked at a traditional, say, 66 kV cable design that used in subsea cables, it would invariably be using a lead extruded design, a dry design of cable. The problem with that is that lead is not a good material for any dynamic or fatigue application. So there have been a couple, and only a couple, of higher voltage cables that have been dynamic in the offshore sector, which NKT, or ABB as it was, provided, where they used a corrugated copper layer to keep the insulation system dry, and then avoided the need of lead for that high fatigue environment. Now that's a good solution, but it's also an expensive solution per meter. What we wanted to do was to ensure that we had a solution that could work in a lower cost environment for offshore floating wind. And so that's one reason why we preferred a semi-wet design. So there's no metallic barrier to keep the insulation system dry. You've still got an outer PE sheath to provide mechanical protection, and it will also inhibit water ingress, but we would happily allow the insulation system to get wet. Okay, that's in contrast to a semi-dry design where an aluminium foil layer is used. And one of the problems in a dynamic application is that the fatigue is always an issue around the outside of the cable. And having a thin foil layer, in our view, would not be adequate for a dynamic application. So we have used a semi-wet design, and we've qualified that to 66 kV really as a means, in addition to the existing market for fixed foundations, but also to be suitable for the dynamic projects. And the first dynamic project this will be used on is the Windfloat Atlantic project in Portugal, as I mentioned earlier, which we're now supplying the cables for. So no, thank you for the question. It's an important issue.
I've just got one quick question. So you've got aluminium. Obviously, you try and avoid using copper for cost. So why copper? Why wouldn't you just use aluminium there in the corrugated designs?
I think, yes, that would be corrosion. Potentially, it may have been to do with corrosion if there was any weakness in the sheath. I'm not sure.
Okay.
But I think that was probably the argument there.
Any other questions? Great. Thank you very much.
Great, thank you. So thank you very much for listening.
Do you have any questions from the audience? Gentlemen at the front here.
Do you think that the floating platform can be a solution for deeper seas like the Mediterranean Sea as far as wind power is concerned?
Yeah, so as you know, there's a lot of interest in floating wind. In Europe, the project which is most developed is the High Wind project, which Statoil, Equinor have off the coast of Scotland. I think that's 5 turbines that's now installed. It started to get operational history. The challenge for floating wind, of course, is to bring the costs down. So it's still a young technology. However, I think there will be a place for it in deeper waters, as you say, in the Mediterranean. And typically floating offshore wind is typically deployed in about 100-meter water depth. So in the Mediterranean, off California is potentially a very good market for it. Japan, of course, is another one, and Japan is quite well developed. But I think probably the industry, my personal impression is that a couple of systems are now going in, the Equinor system, the High Wind system, and the industry is kind of now going to look to see how well these perform, and before we start then seeing the rollout of bigger projects. But I think it definitely will be part of the future.
Thank you very much. Any more questions? I've got one question. So I know, looking at the market before in the kind of Gulf region, people were looking at Aramco's been a big customer of offshore cables for its petroleum infrastructure. Is there any opportunity to kind of link up that, use that infrastructure to link up offshore wind, to import and export in this region?
Yeah, I mean, we haven't seen that yet in terms of inquiries coming in to us, but I think in potential there definitely is. One of the things that I think is of interest as well, and this goes back to the floating wind question, is linking wind power generation to enhanced oil recovery in offshore facilities. And certainly that's some of the Statoil interest is in that, unsurprisingly, because it doesn't matter there, the intermittency isn't the important thing. But you could still use the power generated by the offshore wind in order to power enhanced recovery systems. And overall, that could be a very big market in its own right. Okay, maybe deployed in different ways depending on different local geographies.
Thank you.
I'm probably not the right person to ask, actually. I don't have enough knowledge, really, of the local market to know whether these technologies might replace existing facilities or whether they'll be an addition. I mean, I suspect they would be an addition, but I'm not really sufficiently close to the market to know, I'm afraid.
Gentleman here. Just state your name and your company as well. Thank you.
Yes. Spagnolo from Some Sistemi. Concerning the floating platform and the cable that are used to connect, did you develop some special cable for that? I don't know. I imagine there is some movement of the platform, so the cable have to be adapted to this kind of technology.
Okay, that's a very good question. Can I answer it in a slightly more technical way? If I go back.